Hi guys, so today we're going to learn about AES, which stands for the Advanced Encryption Standard. The first thing we're going to talk about is the main key. So now with AES, your main key size will depend on which version you use. There are three versions of AES. The first one takes a 128-bit key, and with this version we will be doing 10 rounds. I'll explain what a round is later. The next version is 192 bits with 12 rounds, and the last version is 256 bits, and this one does 14 rounds. So I'm going to start by giving a brief overview of all the essential operations that AES does, and then I'll go into detail for each of them. So don't worry if it's a bit overwhelming at the start. So the first operation we're going to look at is key expansion. With key expansion, we're simply just going to be generating a unique subkey from the main key. So we're going to be doing that every round, and it's going to be a different one every round. The next operation we're going to be doing is called add round key. So with add round key, we're going to be simply just taking the plain text as the input, and then we're going to be XORing it with the subkey that we just generated. This will be good for mixing up the plain text, but we're not done yet. There's a lot more we have to do. So the next operation we're going to look at is called subbytes. So with subbytes, we're going to use a lookup table and substitute the bytes in our ciphertext with new ones. After that, we're going to do shift rows, which will shift each row of the ciphertext. Don't worry if that doesn't make any sense. I'll explain how this works later. And finally, we're going to do mix columns, which is a similar operation. It's going to apply a linear transformation on the columns instead of the rows. But it's going to do it with their original positions, not their shifted positions. After this, we are going to repeat everything again. This time, though, we're going to use a new subkey generated from that key expansion algorithm I mentioned earlier. And this is just going to repeat over and over. Depending on which version you use, if you're using the 128-bit version, this will go for 9 more rounds, 11 more rounds in the 192-bit, and 13 rounds in the 256-bit. I should make a note, though, that at the very last round, it will be slightly different. We don't perform the mix columns operation. Lastly, I think it's important to explain a little bit about the internal state of AES. So AES handles things a little differently. We're going to be handling things in a 4x4 grid where each cell is 1 byte of data. So you can see here we have 128 bits as our input. We're going to be taking each byte, or each 8-bit, and putting it into a cell.
All right, so I'm going to jump in here and talk a little bit more about each of the operations involved in AES in a little bit more detail. So on the left here, we have our key expansion. So what we're doing is we're deriving a subkey of 128 bits from a main key, and we're going to represent this as an expanded key. So it's a 4x4 matrix where each block in the matrix is a byte, or 8 bits. And then on the right over there, we have add round key. So what we're going to do is we're going to take the expanded key and XOR it with our plain text, which is our message, and it's represented in a 4x4 matrix as well, like we discussed earlier. That's the internal state. And together that's going to produce another 4x4 matrix where each cell is the result of the key XORed with the plain text. Okay, so next up we're going to talk a little bit about the subbytes operation. So if we look at the top there, we have our 4x4 matrix that came out of add round key. and the first byte in the matrix is S0 prime. So let's suppose that S0 prime is the 8-bit string 01110011. What we're going to do is there is going to be a lookup table available that maps every possible 8-bit string to a new 8-bit string. So we're going to find our string for S0 prime. And there it is. We can see it, the first one written in the table there, 01110011 maps to 00001101. So we're going to build a new 4x4 matrix, and S0 prime is going to be replaced by S0 double prime, which is 00001101. And we are going to repeat this for every byte, essentially substituting every byte in our matrix for new bytes as defined by the lookup table. Okay, so the next operation we're going to talk about is shift rows. So here we have the 4x4 matrix that came out of subbytes, and I've color-coded all of the columns so that it's easier to see what's going on later when we start shifting the rows. So the first column, which is S0 double prime to S3 double prime, is red. The next one, which is S4 double prime to S7 double prime, is blue, and so on and so forth. And to the right, you can see that I've labeled all of the rows. So we have 0, 1, 2, and 3. So when we perform our shift rows operation, it's going to produce a new 4x4 matrix that looks something like this. So it might be a little bit difficult to see what's going on, so let's break down exactly what happened here to produce this matrix. The first row from our double prime matrix is not going to get shifted at all, but then the second row, every cell is going to get shifted over essentially one position to the left. So if we look at the row that's labeled 1, the second row in the matrix, we're going to shift S13 over one cell. We're going to shift S9 over one cell. We are going to shift S5 over one cell. And then the kind of important thing to note is that S1 is actually going to get shifted all the way around back to the spot where S13 was. So that is how shift rows is performed. And the next row, which would be row 2, everything gets shifted over 2 spots instead of 1, and the last one, everything gets shifted over 3 spots. And I'm just going to quickly mark all of these cells with triple primes so that it's clear that this is our new matrix. Okay, so the next operation we're going to be covering is mixed columns. This is the last step in our round before we start all over again with add round key. So mixed columns, we have this set of 4 bytes. If you notice, it's S0, S1, S2, and S3 triple prime, all in red. So it's important to remember that mixed columns operates on cells as they were prior to shift rows. So it's not operating on S0, S5, S10, S15, as is the first column that came out of shift rows. It's instead operating on the original values that were in the first column. So what mixed columns does is it applies a linear transformation, and this is going to give us the final result, which is S0, 4 basically, S1, S2, and S3 to the 4. And that is the end of mixed columns and the end of this round. So we're going to continue for however many rounds there are left as specified by the version of AES that we're using. And this is an example of what one round of AES looks like.